Hello everyone, my name is Lokesh Joshi. In this video, we are going to discuss about the topic of limits. So first of all, let me tell you, we have to define limit, of functions. That is, whenever we are going to discuss about the topic limit, then we should say we are defining limit of a function or on a function. Okay. So for this chapter, our basic idea, what will be the content or what will be discussed in that video. The very first topic is the basic idea of the limit, and I will define that, or I will give you what's the geometrical meaning. Okay, so it will be more clear to you. Now after that, I will give you definition. And the last topic for this video will be left hand limit and the right hand limit. And after that we will do some examples also. So let's start with the basic idea of limit. Now we are discussing what's the basic idea of limit. Okay. So let me tell you whenever we are discussing limit. Okay. So from the limit we are discussing about the behavior of a function. Okay. Behavior of a function at some particular point. Like whenever we are saying limit, then we have to discuss at a specific point. No, we are not taking domain or multiple values at a time. We have to just take a single value, and it will be very clear to you after I give you the next definition. Okay. At some particular point. Okay, suppose we are having any function, let us say y is equal to fx. Okay, so let's draw it. We are having this one as x-axis and this one as y-axis. That's the origin here. Okay, so now let's draw any random graph. Okay, I am not taking any particular function. That's any random graph. Suppose it's like that. Okay. And we can say this is equal to y is equal to fx. And if we are having any point on a domain, suppose it's the x naught. So what limit says? Limit says when the x points are going towards x naught. Okay. When x points are going towards x naught, then where our value of y or where fx is going. Which means if x is going towards x naught, then our y or our fx is going towards which point? Okay, I am not saying the value of fx at x naught. I am saying when x is going towards to x naught, then where fx is going. So let's discuss there. Suppose this point. Okay, this point, let us say, is equal to y is equal to fx naught, and we can also say x naught comma y or fx naught. It will be more appropriate. Now at this point, if we look, like suppose our x is there. If x is going towards x naught, then at that point our y naught is this. At that our y is this. Y, like when x is going towards x naught, our y is going toward that point, like in that way. Similarly, if we look from the right side there, if x is going towards the x naught, then our y is equal to fx is going towards that point. So it's the first case. Okay, now let's take the another graph. Okay, this idea will be same again. Like when x is going towards x naught, we have to discuss where y or fx is going. Okay, now another graph. It's our x-axis. This one is our y-axis. So in that case, I am taking the another graph. Like suppose it's look like that. Okay, there is a break. Okay, again this point, let us say, is x naught, and our graph is y is equal to fx. So if we look, okay, like if x is going towards the x naught, then our function, okay, let us say this point is y1 and this point is y2. Okay, so when our x is going towards x naught, then our function or our value y is equal to fx is going towards y1. Okay, if we are taking from left. Okay, now if we look for the same graph from the right hand side, now if our x is going towards x naught and if we look there, y is going towards the y2. So there is a difference between that graph and the previous one. So let me draw again that graph. This one is the previous one. Now I am drawing that. Okay. Again y is equal to fx. It is same x axis. This is also same y axis. Now what's difference? When we are going towards x naught from any direction in the previous graph, our graph is going towards the same point, y is equal to fx naught. Okay. But in the second one, it's not same. Okay. So now it's the idea, like when we can say limit exists or what's the limit. So in every function, when our value of domain, like it's, let us say x, when it's going towards x naught and our value of the function y going towards the any single point, or we can say if from left or right we are going towards the single point x naught, then our graph, or we can, yes, for that one let's only talk about the graph. If our graph going towards any single value, then we can say limit exists. Okay, but in the second case, what's the scenario there? If we are going from the left, we are going to y1. If we are going from the right, then we are going towards the y2, and from the graph we can clearly see y1 does not is equal to y2. So in that case we will say limit does not exist. Okay. So it's the basic idea of limit and the geometrical meaning what's given there. Now after that I will give you the proper definition and we will do some questions also. Now we are discussing what's the definition of the limit. Okay, so it's written there, limit of a function describes the value that a function approaches as the input approaches at a particular point, which means suppose we are having a function, okay, any function. Again I am taking the same example or we can define from the graph. Suppose it's a function and we have to find it x naught. So whenever value from the domain is going towards the x naught, then we have to find where the graph is going. Okay, suppose at that point, initial point, okay, that point, our function y is equal to fx, okay, going towards at that point, let us say this is y naught. Okay, so when we are going from the left, we are going towards y naught, and same from the right side. So limit of a function describes the value, okay, the value that a function approaches as the input approaches at a particular point, and the point here is the x naught. So if we write that things, it's there. When fx is given any function and c is any point in the domain, okay, which means we have any function, let us say fx is equal to x, okay, I am taking very easy example for better understanding, and c is any point in domain. Okay, so let's first of all describe the domain. Let us say our domain is open interval 0, 2. C, then take c is equal to 1. Then limit of function fx as the x approaches c is denoted as limit. We read it as limit x tends to c, fx is equal to x. So from that example it will be very clear. Okay. Now the graph for fx is equal to x will be, this one is the x axis, this one will be y axis, it's the origin. Let us say these points are 1, 2, 1, 2. Now we are discussing about fx is equal to x. So graph will be like this. Okay. So our domain is 0, 2. So it will be like that. Okay. 0 and 2 are not included in the domain. So now we have to discuss. Okay, let me write this thing. Limit x tends to 1. Fx is equal to, we have to find, okay, fx. We have to find. Now, what's the fx in that question? We have given fx is equal to x. So we should write x. limit x tends to 1 x. Now if we are going towards 1, where our function is going, at that point if we say, then it is 1 comma 1, so our function is going towards 1. If we are going towards 1 from the right side, then where our function is going, at the point 1 comma 1. So we can say when any point from our domain x going towards 1, then its limit is equal to 1. Okay, so L is that value of the function where our fx is going. Okay, so that's for the definition of a limit. Now we are ready to define what's the right hand limit and left hand limit. So the at the starting I am telling you, when we are going towards the left, it's the left hand limit. When we are going towards from the right, then it's right hand limit. So let me give you proper definition and actually what they are. Now we are defining what's the left hand limit and the right hand limit. Okay, so the short forms for that we write LHL for left hand limit, which means whenever we are having any function, okay, whenever we are having any function and we are looking at any point x naught in the domain, okay, so left hand limit tells like when we are approaching towards x naught from the left hand side, then our function going towards which points. Okay, so how we can write that? We can write LHL is equal to, okay, limit x tends to x naught, and we have to write minus there, which means we are going towards x naught from the left hand side. Okay, fx, it's how we can denote the left hand limit and how we can find. Okay, so it will be limit h tends to 0. Okay, h is the number which is very near to 0, and we can write f x naught minus h. Okay, at the point x naught we are finding, so let me tell you again, LHL we can denote it limit x tends to x naught minus fx, okay, is equal to limit h tends to 0 f x naught minus h, the same thing. And one thing there, the h is greater than 0. Okay, now similarly we can define right hand limit also. Now we are having any function, okay, let us say it's the point x naught, and let's draw only right part. Okay, so when we are going towards x naught from the domain, then where our function is going. Okay, so that point will tell us about right hand limit. Okay. Now we can write RHL or right hand limit is equal to limit x tends to x naught. Now in that case we have to write plus. Plus is there like we are going towards x naught from the right hand side. Fx is equal to, like how we can find, limit h tends to 0 f x naught plus h. Okay, so these things there, in the left hand limit we have to put minus, in right hand limit we have to put plus, and the things are like that. Okay, and one thing is same, h will be greater than 0. Okay, now if we solve a question for left hand limit and the right hand limit, then it will be very clear. Okay, so now the last part of our video, we are going to discuss a solution. Now it's a question written there, we have to discuss like how we can find LHL and RHL. So our given function is fx is equal to 4x plus 1. So let's start from LHL, which is left hand limit. So first of all we should identify the point at which we have to find. So we have to find the LHL and RHL at the point x is equal to 3. So first of all, how we can write LHL, as we have discussed, limit x tends to x naught, or at the point we have to find, it's given 3 here, right, left hand limit, so minus f x is equal to limit h tends to 0, f at which point we are finding 3. So 3 minus h. Now we have to put 3 minus h in that function fx or 4x plus 1. We will find the value of LHS. So it will be limit h tends to 0. If fx is 4x plus 1, then what will be the value of f? 3 minus h. We have to just write the same thing, but in the place of x we have to write the 3 minus h. So 3 minus h plus 1 is equal to limit h tends to 0, 4 3s are 12 there, minus 4h and then plus 1. Okay, so is equal to limit h tends to 0, 12 plus 1 is 13, minus 4h. Okay, now 13 is a constant there, so it will be same. 13 minus limit h tends to 0, 4h. If we put 0 there, okay, for that, so it will become 13 minus 0 is equal to 13. So we can say for that function value of LHS is equal to 13. Okay. Now in the same way we have to find the value of RHS. We are finding at x is equal to 3, so let us write LHS is equal to limit h tends to 3 plus f, and we have to find the function is our this fx. So it will be limit h tends to 0, f 3 plus h. Okay, that thing. Now just like the LHS, we have to put the value of fx there and we will find the answer. So this thing will be from there limit h tends to 0, fx, so it will be 4 3 plus h plus 1, okay, is equal to limit, we have 4 multiply 3 plus h, so it will be 12 plus 4h plus 1. It will be limit h tends to 0. Now it will be 13 plus 4h. 13 is constant, so I can write 13 plus limit h tends to 0 for h. As h is going towards 0, so that value will become 0, and we can say our RHL will be 13. Okay. Now there we have find LHL is equal to 13 and we also get RHL is equal to 13. So it's the answer for this question. LHL and RHL both are same in that question and value for that is 13. So at last let me tell you one thing. Okay, so it's a node. Okay, we say the limit of a function exists, so we can write like that. Limit x tends to any point x naught, fx is equal to L. Okay, in which case when RHL is equal to LHL. Okay, then we can say limit of a function exists and it will be same is equal to L. So in this question LHL, RHL both are same and value is 13. So we can say limit x tends to 3, fx is given there is equal to 13. So I hope this question is clear to you. Now it's all for this video. I hope to see you again.